In this short video I'm going to review the exponent laws that you should have learned and remembered from grade 9 math. Exponent is a fancy way of saying power. So there is a number raised to a power. The number itself is called the base, and the power, the proper name for the power, is called the exponent. And it simply tells you the number of times that the base is multiplied by itself. So 2 to the 5 is 2 multiplied by itself 5 times. 2 times 2 times 2 times 2 times 2. And that works out to be 32. Similarly, 3 to the power 4 is 3 times 3 times 3 times 3, which is 81. Another example, 5 to the power 3 simply means 5 times 5 times 5, which is 125. So really, exponents is dealing with the number of times that the same number is multiplied together. So, one of the most simple operations you'll be asked to deal with in exponents is multiplying numbers written as exponents together. In this example, 7 squared times 7 cubed. Well, 7 squared simply means 7 times 7, and 7 cubed means 7 times 7 times 7. Now, multiplication, the order doesn't matter and the hierarchy doesn't matter. 1 times 2 times 3 is the same as 1 times 2 times 3, and so on. So realistically, we have 7 times 7 times 7 times 7 times 7. Altogether, we have 7 multiplied by itself 5 times. So what this effectively done is lengthen the chain from initial 2 and added another 3 to it. So all we do is add the exponents. Here's another example. 8 cubed multiplied by 8 to the 4. Well, 8 cubed is 8 times 8 times 8, and then we're going to multiply it by 8 times 8 times 8 times 8. And what that's done is lengthen the chain from an initial 3, and we've added another 4 to it. So altogether, this is 8 to the power 7. So in general, when we're multiplying numbers involving exponents, provided they're written to the same base, we add the exponents. Being the same base is really important. 2 cubed times 3 squared, 2 times 2 times 2 times 3 times 3. We haven't lengthened the chain of 2's, and we haven't lengthened the chain of 3's. We cannot simplify this expression and write it in some more compact way. So the base numbers need to be the same, otherwise the rule doesn't work. Similarly, when we're dividing, the same kind of thought process occurs. 8 to the 6 divided by 8 to the 4. Well, this on the numerator is 8 to the 6, and we're dividing by 8 to the 4 underneath. And we can cancel common factors top and bottom. And we can cancel 4 eighths. And what this effectively does is reduce the length of the chain from 6 originally to only 2 now. So we're left with 8 times 8, which is 8 squared. So when we're dividing numbers with the same base, all this does is reduce the length of the chain, so we subtract the exponents. One more example, 7 to the 5 divided by 7 squared is 7 times 7 times 7 times 7 times 7 divided by 7 times 7. And now we can cancel the 7's top and bottom, and what we've done is reduce the chain by 2, so we're left with 7 cubed. The last operation which you discussed in grade 9 math was raising a number to a power to another power, and in this example we've got 4 cubed raised to the power 5. Well, raising it to the power 5 simply means that we multiply it by itself 5 times. So it's 4 cubed times 4 cubed times 4 cubed times 4 cubed times 4 cubed. And we've already discussed earlier that when we're multiplying numbers with the same base to different exponents, all we do is add the exponents. So we've got a 3 plus a 3 plus a 3 plus a 3 plus a 3. And of course that is 5 threes, which is 15. So when we raise a number with an exponent to another exponent, all this does is repeat the length of that chain that number of times, so we multiply the exponents. So if we had 2 to the 4 cubed, then this would be 2 to the 4 times 2 to the 4 times 2 to the 4. Now doing this in full, this is 2 times 2 times 2 times 2 multiplied by 2 times 2 times 2 times 2 multiplied by 2 times 2 times 2 times 2. So what that has done is repeated the chain of 4 3 times, so altogether we now have a chain which is 12 long, and of course 12 is 3 times 4. When we raise a number with an exponent to another exponent, all we do is multiply the exponents together. So, to summarize, when we multiply numbers involving exponents together, provided they have the same base, we just add the powers. When we're dividing numbers with the same base to exponents, we end up subtracting the powers. The division simply shortens the length of the chain. And when we raise a number written as an exponent to another exponent, all this does is repeat this length of chain that many times, so we end up multiplying the exponents together. Let's have a look at these 3 examples. Please pause the video and try to figure these pretty easy ones out for yourselves. Well, how did you do? 11 to the 8 times by 11 squared, well, numbers to the same base, so all we do is add the exponents, so this is 11 to the 8 plus 2, which is of course 11 to the power 10. In the second example, this is 17 times 17 times 17 times 17 times 17 times 17 times 17, and we're going to divide it by 17 times 17 times 17, and of course what this does is reduce the length of the chain by 3, and we're left with 17 to the 7 minus 3, which is 17 to the power 4. And finally, number 3, 5 squared to the power 4. Well, this means 5 squared times by 5 squared times by 5 squared times by 5 squared, and of course this is just 5 to the 2 plus 2 plus 2 plus 2, which is 5 to the power 8. How did you do? I hope those made sense. It's really important that you know these rules and you learn them and you can apply them easily. But remember, these rules only work if the numbers have the same base.